solve this system of equations, we have a set of simultaneous equations. By inspection, we can see that x, y equals 1, 0, 0, 1 are two sets of solutions of the equations. However, it's not always possible to find the solutions by inspection. So we'll now solve the problem using a systematic approach. From equation 2, we have x to the power of 4 equals 1 minus y to the power of 4. Because y to the power of 4 is greater than or equal to 0, so x to the power of 4 is less than or equal to 1. So x squared is less than or equal to 1. That is to say, minus 1 is less than or equal to x is less than or equal to 1. Similarly, we know that minus 1 is less than or equal to y is less than or equal to 1. Multiply both sides of equation 1 by y. We have y x cubed plus y to the power of 4 equals y. Equation 2 minus equation 3. We have x to the power of 4 minus yx cubed equals 1 minus y. By rearranging the equation, we have x to the power of 4 minus 1 plus y minus y x cubed equals 0. By grouping terms, we can write x to the power of 4 minus 1 minus y times x cubed minus 1 equals 0, which can be written as x minus 1 times x cubed plus x squared plus x plus 1 minus y times x minus 1 times x squared plus x plus 1 equals 0. By further factorization, we can write the two terms as one term, as the two terms have a common factor, x minus 1. So we can now write x minus 1 times x cubed plus x squared plus x plus 1 minus y times x squared plus x plus 1 equals 0. So either x minus 1 equals 0. So x equals 1. From equations 1 and 2, we can work out y equals 0, or x cubed plus x squared plus x plus 1 minus y times x squared plus x plus 1 equals 0 if x squared plus x plus 1 doesn't equal 0, then we can work out y, because x squared plus x plus 1 can be written as x plus a half all squared plus 3/4 by completing the square. X plus a half all squared plus 3/4 must be greater than or equal to 3/4, which doesn't equal 0. So from equation 4, we have y equals x cubed plus x squared plus x plus 1 over x squared plus x plus 1, which can be written as 1 plus x cubed over x squared plus x plus 1. If x is greater than 0, from equation 5, we can deduce that y is greater than 1. We have a contradiction, as y is less than or equal to 1. If x is less than 0, then x cubed is less than 0. From equation 1, we can deduce that y is greater than 1. We have a contradiction, as y is less than or equal to 1. So x equals 0. From equation 5, we can deduce that y equals 1. In summary, x, y equals 1, 0, 0, 1 are the only sets of solutions of the equations. Thank you for watching. Hope you found this video helpful. Please subscribe to this YouTube channel for notification of new videos. See you next time.